The early universe, a cosmic construction site 13 billion years ago, was a place of intense activity. Stars were born at a dizzying rate, giving rise to the first dwarf galaxies, destined to merge and create the colossal galaxies that populate the cosmos today, including our Milky Way. Until recently, the details of this tumultuous formation remained shrouded in mystery. Thanks to the precise measurements of the Gaia Space Telescope, which has mapped the position, brightness, and distance of over 1 million stars in our galaxy, a team of astronomers has finally lifted a corner of the veil on this fascinating cosmic story. The results of this research, published in 2019 in the prestigious journal Nature Astronomy, shed new light on the early stages of the Milky Way's formation. Previous studies had already revealed that the halo of our galaxy, the kind of luminous halo that surrounds the stellar disk, was composed of two distinct stellar populations, one younger and richer in heavy elements, and another older and poorer in metals. Astronomers had identified the first population as the remnants of a dwarf galaxy, called Gaia Enceladus, which had collided with our primordial galaxy. However, the origin of the second population and the timing of this collision remain to be clarified. New analyses of Gaia data have allowed for a more complete reconstruction of the event. About 13 billion years ago, two distinct stellar systems began to form the first stars. On one hand, a dwarf galaxy, Gaia Enceladus, and on the other, a much more massive and metal-rich system, destined to become the progenitor of our Milky Way. About 10 billion years ago, these two systems collided in a violent crash. The impact was so violent that it projected the stars of both galaxies into chaotic orbits, giving rise to the halo of the Milky Way. In the following eons, our galaxy continued to grow through intense episodes of star formation, until about 6 billion years ago, when the residual gas stabilized into a thin disk, giving rise to the disk structure that characterizes spiral galaxies like ours. This discovery represents a fundamental step in understanding galaxy formation and offers us a clearer view of the early phases of our universe's evolution.